So welcome everyone. So today we are going to understand about a deep learning technique called as zero shot, one shot and few shot learning. Okay, so here in this approach we are going to understand about the scenarios where we have little to no labeled training data for new classes or a task. Okay, if we have no training data or if we don't have any new classes or a task, what we can do and what we can adopt. So this is an architecture for this. This is an architecture for zero shot, one shot and few shot learning technique. So we are going to understand first one by one by using this technique called as zero shot learning. Here, as you can see, we will have a class definition. Like what task we are eventually going to do here. Okay, we'll determine the label availability. What are the different available labels? Okay, what is the class labels here? Okay, according to this, there will be a zero shot technique. Okay, zero shot means there will be no example available for the target variable. Like what you have to do. We are not giving any type of example over here. For example, if you want to do question answering task, we will not provide any type of questions here. We will just provide a text. Okay. And what task we are going to do. Okay. Based upon that, it will going to understand and give us the result. So this technique we can start by identifying first is your semantic relationship within our databases. Whatever our database is, okay, whatever is model are trained on, within that we will understand the semantic search. Like how is a new class related to the known class? For example, if there is zebra, which will relate to like a horse. So what is the difference there? The stripes. Strips are the difference. Okay. So you will use that semantic search relationship. We will understand that whether it is a horse or whether it is a zebra. And based upon this, we are going to use a pre-trained model. For example, if we are using our task definition, for example, we are using question answering task, or if we want to generate something, okay, if we want to summarize something, likewise. So based upon that, we will select our pre-trained model. Based upon that, we will select our pre-trained model. Okay, pre-trained models like CLIP. So in our today's scenario, we are going to use a pre-trained model called CLIP. Okay, contrastive language image pre-training technique, which is also following our BERT or a GPT model. Okay, here is the input map to the semantic search. Then we will have an input match, which will relate to the semantic search relationship between them. Okay, what is a semantic semantic search representation within our database, wherein our pre-trained model is trained on. Okay, our pre-trained model is trained on multiple billions of the data. Okay, at the back end. So we need to search from this use case our task definition. Based upon this, we are using a zero shot prompt technique wherein we are not giving any labels. Based on the semantic search operation, we can map our labels here. We can map our output labels here. Okay, if we can, we will use that particular operation. For example, if you want to use it for sentence transformer. Okay, accordingly, what we will do, we will have our cosine similarity. Okay, similarity scores we will form. Accordingly, we will form a similarity scores and based upon that, the output will be generated. Okay, so we'll understand in the use case part when and how we can use this particular thing. Okay, like if we want to use it for classifying the social media contents for new event labels that are never in your training data. That is never in your training data. But we can fine tune this particular model according to our use case. Okay, so here what are the different challenges when it comes to zero shot learning? So mapping accuracy can drop when the semantic search or the semantic thing is not there. Okay. Based upon our pre-trained model, we are doing a semantic search. Okay. Whatever is there in the task definition versus what is there in your pre-trained model. Based upon that, we will form a semantic score. So if the accuracy of mapping will drop, the accuracy will also drop. Likewise, this is a language model may hallucinate, guys. This can hallucinate. Okay, or generate inappropriate results also. Since we need to do some examples, something we have to specify, then only it will work according to what we want. So we'll need to fine tune this pre-trained model so that it will act accordingly to our business problem, whatever the task we want. Okay. Likewise, there is also one thing called as one-shot learning. So here in the one-shot learning, we will assume that we have one labeled example for a new class, whatever the new class we are taking. We are giving one example. Okay, instead of no example, we'll give one example. This is the question and this is the answer. Okay, for example, what is data science? We'll provide one answer to this question and we can use it for question answering task. Okay. Likewise, for one-shot prompting, it will assume that one labeled example for the new class is given. And then by using the reference example means this one example. We will take that one example, we will choose our model with that one example, and then we will compare what we can do, what we can have as an results. All these things we will understand from. Now, what is the use cases of this? Face unlocks in the phone. Okay, based upon our face, when we are having a locking system in our phone, logging attempts are there. Okay, so whenever the new face will be there, it will not open. Face will unlock based upon the person's, okay, whatever, whose phone is that, based upon that, login attempts will be occurred. Okay, so this is one of the use cases of one-shot prompting. Like one example. Likewise, what are the different challenges when it comes to one-shot prompting? So one example might not be representative. Even for a difficult task or for a very time-consuming task, or if the task definition is even more depth, okay, one example will not be enough. So this is one challenge. One example might not be representative. Okay, it might have noise in that. It might not be, we can say, sensitive to noise when it comes to image data. One image we are showing and one label to that image we are giving, for example. So that example would not be the good option for them. Okay, some noises will be there in that data. Okay, it can lead to noise also and give you the wrong output also. Misclassification also can occur. Then there is few shot promptings. Within the few shot promptings, what we are having, we will select the support system. Within the few shot prompting, the first thing is we are going to give few examples. Instead of one example, we are going to give few examples. Few means we will going to give like 3 to 10 examples per class. We will select our support system. Okay, we will select our support set, a mini data set of examples we will take, and from that we will choose the model. Now model, how we will going to choose the model? By using a prototypical network. Okay, it will compute a centroid of each class in an embedding space itself. Also, it can also be useful for matching the networks. Okay, also it can be useful for meta learning approaches. Okay, so we'll iterate over all the support examples and we will find out the appropriate results for this few shot promptings. Okay, so this few shot promptings, we can use it for fraud detections on new transaction patterns when we are giving some fishy along with spam and ham, both the things we are giving. So based upon that, it will understand that whether there is some patterns of transactions. Okay, so whenever the new transaction will happen, it will give us that whether it is a fraudulent one or it is not a fraudulent one. Okay, so what are the challenges when it comes to few shot prompting or few shot learning is model will overfits with the small support sets. Okay, very small number of data also, since we are giving some examples over here. So it can be overfitted also. Our model can be overfitted also. Also, feature drift can occur. If the support set isn't updated, model weakens over time. Model can weak over time. Okay, so we'll see all the interference about this and then we will classify the output. It is, what are the challenges here means? It will be not good for unseen or a new data. Whenever the new data will come, maybe it will not going to give you a proper outcome. Okay. So here the interference and model behavior. When it comes to interference and model behavior, regardless of which path we are choosing, like 0 prompt, 1 prompt or few shot, okay, the goal is to make the interference on unseen classes only. Whenever the new data will come, how it will going to perform. This is our ultimate approach after all these. The model doesn't retrain. It adapts by comparing the inputs to semantic embedding. Okay. And it also supports the sets within that. Okay. So here now in this part, we have understood that there is one thing called as zero shot learning, wherein we are not going to provide any labels. No labels will be available. Okay. Solely based on the pre-trained model, it will going to search on the semantic models. Semantic search we will going to do on the test definition or the task definition versus whatever the outcome is coming. Then there is one-shot prompting where you can compare your inputs with just one example. Then there is few shot promptings. When you have trained your model with small label support data set, you can use that model particularly given this few examples. Okay. So this is our few shot prompting. So we have understood here that to classify an image, here there will be no example given. Here at least one example will be given. Here few examples will be given. Based upon this, we will identify which approach is going to give you for unseen data or whatever the new data will be coming. For that, we are going to understand which approach will give you the better outcome or better result. So let's take one example here. By using this clip, we are just manually downloading this clip over here. We have taken the URL of this clip and directly going to use it here in this runtime. I have already used this and run this because it is time consuming. I have already done this task. I will going to showcase you what is the output it is giving me. So I have taken one random generated image which is given by any of your chatbots. Okay, it is a generated image, not the original image. And there are some classes that I am taking here. You can see here I am using a vision transformer. Okay, as a model, we are using this vision transformer. Okay, and here the classes are either it is a dog, either it is a cat, either it is an illustration, or either it is a car. So since our image is a generated image, it should give us the illustration as an output. Okay, so here you can see when I'm running this particular model, clip model, okay, it is giving me the confidence score of a dog, cat, illustration and a car. So you can see here, illustration, it is giving us 82% probability. Likewise, for one-shot prompting also, I am having this approach, okay, taking the image and the query image, you can see the same versus different. Okay, same versus different classes. For the same class, it is giving me this much accuracy, and for the different class, either it is from the different class or the same class. So it is giving me this. So it is from the same class only, interference class only. That is why it is giving me this confidence. Likewise, for the few shot promptings also, Here, why this point is coming means I have converted that into a torch. Okay, I have taken the model, I have used the embedding, which is a numerical representation of the inputs, and that is when it is giving us the output as a numerical, okay, or a vector representation of the outcome. You can see for this class also it is giving me, here I have taken this 0, 0, 1, 1, 2. Since we are having this classes, number of ways as 3, number of support as 2, and number of query we are taking as 2. Okay, so it is giving me the output as this. Okay, as in predicted classes, this. Okay, so here we have understood that in the zero-shot prompting, it will predict with no training images. We have not trained any images. Okay, we have just used the clip matches images, and we have used the generalized prompt which is present within the clip model. In the one-shot learning technique, we have understood that it will match the classes with at least one known example. What one known example? The known example is illustration 1, which is there from the above image which we have taken. Okay, so at least from one class which we have taken, it will show us the output, and we will compare the difference between, like comparing the feature difference between the classes, whether it belongs to same class or not. Okay, then in few shot prompting, it will learn the concepts. It will learn the concepts based upon few examples per classes. So we have taken some examples over here, and then we have supported the examples per classes too. So you can see per class, there are 3 classes and we have taken 2 examples per classes. Okay. You can see 0, 0 is one class, 1, 1 is one class, and 2, 2 is one class. Okay. So one class, 2 images we have taken. So we are taking a few examples, few shot learning we are doing. By using what? By using a protonet. By using a protonet. You can see protonet. This is the name of this particular model. Protonet. Simple protonet. Okay. Which will use your class label accordingly. Which class label? This class label, which we have assigned earlier. The cat, this. The cat, the car, and the illustration, or the car, whatever. Okay. Based upon this, it will give you the outcome. Okay. So I hope this is understood. Okay. So today we have understood about zero shot, one shot, and few shot learning. How we are going to do? We have taken the examples of this. We have run the code also for this. And we have understood that which will give you the best result according to the task definitions. Okay, that we have to check accordingly. We have to take with zero shot, we have to take with one shot, and then few shot. Then we have to check which one is giving us the better interference for unseen data or unseen classes. Okay, so thank you for today. So this is our contact number. You can contact us or you can mail us if you want any inquiry. Our salesperson will call you. This is our offline classes center. Okay, you can just enroll here also. You can visit our office also for inquiry. Okay, thank you guys. Thank you for joining. We'll meet you in the next with a new topic on the next lecture. Thank you. Thank you so much.